Today we have to do logistic regression, which is used for, we can say it is used for classification, right? So I'm sharing my screen. Yeah. Okay. So what is logistic regression? Like logistic regression is a way of classifying the our features, right? So logistic regression, for example, if we have to tell whether our data should be classified in which way. For example, data for classification. Suppose if your target variable is in the form of yes and no, then we can say there we have to use the uh, yes, for example, this one. For example, we can say that okay, I have sample here. Yes, you can take example of this one. Like so, based on the R we studied, based on our previous score, it will suggest, it will predict whether we can pass or not. So one is for yes and 0 is for no. Okay, so whether we will pass or not. Okay, so in that scenario, in that kind of data, we have to use logistic regression. So it is used when the dependent variable is categorical, like binary outcome is 0, 1, true, false, dog, cat, yes, no, like this. Then we will use this logistic regression model, the probability that a given input belongs to a particular category. So the equation we have here is this one, in which our all the equation from the linear regression is same. This is from multiple linear regression. This data you can see a lot of features you already have here, right? So what we have to do, we just have to put it in our formula. This is not a formula, by the way. Here they are doing the log natural log probability of an event to occur and probability of event not to occur. So there is they are doing it. This is the different formula, by the way. The output is the probability score between 0 and 1. Okay, so if we go down a little bit, so it's so linear logistic regression is a supervised learning algorithm used for classification problem. It is used to predict the probability of binary outcome like 0, 1 and all this. So key difference of the from linear regression is a little bit, it is different from the linear regression, that is the output will be unlike linear regression which predicts a continuous value. So your linear regression is for the continuous data, like for example 10, 9, 8, 8.1, 8.2, something like this, right? But here, this logistic regression gives the answer in only two format, like yes, no, and all this. Basically, and the line is also different. In linear regression, you have the straight line, but here, the logistic regression, we have sigmoid. What is the meaning of it? For example, you have the curve like this. So you won't get a data, you won't get a line like this in your data, not like this. So what line you will get in the logistic regression? It will look like this, sigmoid, right? You can say these are the 2 points only. Maybe you can say this is for yes, this is for no. Amit Singh, you can turn off your camera, it's okay. Okay. So whatever, like whatever,
Sorry, sir.
uh, whatever input you take in here, this is your independent variable here. For example, like you are putting the weight of the mouse, and and this curve will tell whether that mouse is obese or means fat or not, right? In that scenario, what we can do, uh, your 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 graph can work like this. If you give weight like you can say 200 grams, it is not obese. 300 not obese, you can say 400 not obese. But after 400, all the mouse will be obese, right? So you must be thinking like why we need this, why we need this logistic regression. We can simply do like the mouse which is having less than 400 grams. We can tell them that this is fit, not obese. And mouse which is, we can say, the greater than 400, we can simply call them obese, means fat. Why we cannot do this simply? No, we cannot do it because the reason is just to define the obese parameter. We cannot just see the weight and just tell it. Sometimes what happens, there is other parameters also, right, to define whether a person is obese or, like height is also there, weight is also there, fat percentage is also there, muscle percentage is also there, lot of features we have, right? So in that scenario, what we will do, we'll use the logistic regression, in which it gives you the ability that you can put the height, you can put the weight, you can put the fat percentage, right? A lot of features you can put over this in this equation. And what it will do, so the equation is 1 by 1 plus e to the power minus, and all of your this equation, linear regression equation. So what it will do, you will put all this equation here, all these features, and it will turn it to into 0 or 1 format. Okay, so this equation is very useful. This one, you put all the features here and it will give you answer in 0 and 1 format, right? So that's why we use this sigmoid. Logistic regression applies the sigmoid function to a map, predict values to probabilities between 0 and 1. Okay, so in this equation, what it is telling that what is the meaning of Py is equals to X is a probability that the dependent variable is 1, the event happens given the feature set X. So this is the your target. You can say your output. And what is this? These are, the coefficient, or you can say weight. Suppose weight of the, let's not confuse you. Suppose fat percentage of a mouse, how it is important. So there must be some weight. No? It is very important, and you can say how much weight is important for determining whether a mouse is fat or not. It is very important. That's why the coefficient is very big one. How much height is important? Height is also important, but not very much. Okay, so this is how the equation goes, right? Okay, then what we have x1, x2, xn. These are the independent variables. So this is your x-axis and this is your y-axis. E, the Euler's number, which is 2.718. So that will be done automatically, by the way. The result of the formula is a probability, which is then converted into binary outcome using a threshold 0.5. Suppose if after solving all this equation, if your values is below 0.5, it will give the output at 0. If it is beyond 0.5, it will give at 1. If the probability is greater than or equal to 0.5, the model classifies it as a 1, otherwise 0. If you plot the graph of this function, you will see that it will make a sigmoid. Let me show you sigmoid function graph. How does it look like? It looks like this. Okay, all the things we have done. Okay. Okay, now let's do the coding. So here we are taking an example, like example is logistic regression in Python, how to do it. So let's implement logistic regression to classify whether a student will pass or fail based on the R studied and previous score. So we'll save this in the Python. So import your libraries Python, NumPy, Pandas, test train split, logistic regression, and for accuracy score, confusion matrix. Make your data in a dictionary format like this. Previous scores, whether person is pass or not. 0 is fail, 1 is pass. So make a data frame of your this data and just select these two columns. First column R studied and a previous score as a your x-axis and parsed column as a y-axis. Yes. Split the data in the two part, like 80-20%, 80 for training, 20 for testing. Okay. Then okay. Then you can make a object of logistic regression. So fit your data here, okay, and it will fit your both the data here, and then your model will predict. Pass your testing data. It will predict something. So okay, let me run this and let's see what is the accuracy score, our predicted one and our testing data, and what is confusion matrix. Confusion matrix is 2. Okay, what is confusion matrix? Tell me that in the chat. What is confusion matrix? Tell me in the chat. No answer.
सर टेबल जो क्लासिफिकेशन प्रॉब्लम को रिजॉल्व करने के लिए होता है, एक तरीके की टेबल होती है सर, जो क्लासिफिकेशन प्रॉब्लम।
Just wait. 2 by 2 matrix between predicted and the actual contains false positive, false negative, true positive, true negative. Yes, correct. Very nice, Sarthi. Amit Singh, yes, correct. ठीक है. So basically accuracy score is 0.6, which is 66%. So out of I think 6, out of 6 it just predicted 3, I think. Out of 5 it predicted only 3. Correct prediction. And this is your confusion matrix, right? Okay, so what I'm doing now, that you can see the code here, which is very simple, right? Okay, I'm giving you one data for this one. You people have to do the classification, okay, using a logistic regression. Just 1 minute. Okay, this is the data in front of you. Heart disease data set, okay, in which you have these 8 columns: age, sex, your CP, which is chest pain type, trust, BPS, resting blood pressure. This is diastolic or systolic? I think this is the first one, diastolic. Resting blood pressure in mmHg on admission of the hospital. Okay. Then we have cholesterol, which is this, and fasting blood sugar. We can see it is in yes or no. Resting ECG, maximum heart rate. Okay. Exercise induced angina, and then old peak ST depression induced by exercise. Okay. So see, you can see that every column is a numerical. So you don't have to convert it into numerical, right? So I'm giving you this data. Take it and please do the logistic regression and tell me what is the accuracy you are getting. This is your code. Anybody who has done it? Aarti, Amit, Amruta, Ankur, Ashish, Charan, Gaurav, Jafar, Jayashree, Kunal, Nikhil, Robin, Satyam, Shubham, Sonu, Sukanya, Umer. 0.78 is the okay, is the accuracy. Okay. And also print the confusion matrix. Hmm, 71 and 90 is rightly classified, and 31, 13 is a wrong classification. Okay, 78% is fine. Fine. People are saying that wait, let me. People are saying we are getting this value. Um, Actual true and predicted true is 71, and false positive is 31. This is 13. This is 90. Okay, so this is true prediction, but this is very dangerous. This one. This is very dangerous. False negative. We have to reduce this because your model is saying that yes, person have the heart disease, but your prediction is saying it is no heart disease. That person will die because if he will not, if he will rely on this model, our logistic regression, he will die because the person really has the disease, but our model said that he don't have the disease, so he will not take medication. This can be still like tackled because your model is saying actually that person was not having heart disease, but your this model is saying he have the heart disease. It's okay. This is okay, but this is not okay. Okay, so try to like reduce this. Maybe we can do this with the help of using different algorithms. Okay, so in the feature selection, we will do we will do some of the you know feature engineering we will do. So there I will tell you like how we can improve our model, right? So there is the various ways to improve the model. Okay. Wait, what about others? Only one student given the answer out of 19. What about you? What about the others? Please write in the chat. Hello, others, please answer. Nikhil, have you done? Aarti, Sukanya, you? Some people who used to answer today, they are not answering. What happened? Aarti, sir, I'm still doing. Okay, I'm waiting. I'm waiting. Do it fast. I have to do the next word, next algorithm also. Okay, so what is accuracy? Accuracy measure the percentage of correct prediction out of all the prediction made. And confusion metric provide insight of true positive to negative false. So how can we visualize the sigmoid function using this example of heart disease? So okay, you can try one more thing. You have your, but see, okay, let me tell you one thing. From this data, let me try this data according to this data. If I print my x, wait, first of all, let me see all the values. Okay, x is this two-dimensional data and y is one-dimensional data. Y prediction is also one-dimensional. Import matplotlib dot pyplot as plt, right? Plt dot plot there will be some dimension issue because your x is 2 dimension and your y is only 1 dimension. Uh, See here, your output is 1 dimension and your input is 2 dimension. So not possible to make it. Yeah, both dimensions should be equal. If you have one independent, one dependent, then you can easily make it like this, like which I showed you. But your input is 2 dimension and your output is 1 dimension. So like you cannot make it. Okay, what about Aarti? Have you done your accuracy? Yes, see this. If I'm choosing 1 dimension from the x and 1 dimension of y, then we can plot it. Now it's looking like sigmoid a little bit. If you use our study, so x is previous scores. Suppose your previous score is 70, then you will fail. 75 fail, 80 fail. More than 80, it will be pass. So previous scores and your pass and fail is your you can see. It is not very smooth because we don't have much data. That's why it's not smooth. But you can easily see your y is classifying it. If you want to see the prediction, let us see from X train. Okay, let me see X train. X text. Okay, so from here I'm taking only uh, X text. Okay, previous course I'm taking and Y will be the prediction. Let us see what our model has given us. So our model is saying 70 and less than 70, 72, 74, 75, 78 all are fail, but above 80, 80 and 82 is passing. So this is our model predicted. So this is your testing data and this is your model prediction whether it will pass or fail. So the model is predicting this, right? Arti, have you done? And I didn't get any output. Okay, let's now create for our study. So if people are studying 50 less than 15 hours, they are fail, otherwise they are pass. Okay, no worries. So in the next session, what we will do, we'll do logistic regression is a classification method, right? So in the next session, what we will do that we will do decision trees, okay, or maybe support vector machine, k nearest neighbor, all this tomorrow. Fine. Arti, if you want to ask anything, you can ask me. If you want to share the screen. So basically, logistic regression is widely used in the field of medical diagnosis. Okay, like whether a patient has a disease or not, just like we are doing in the heart disease. It is also used in marketing, whether a customer will buy a product or not. Okay, this kind of. Okay, suppose your data is in continue. Suppose your data is string data. How will you convert it into numerical? Anybody? Using dummy variables or yes, right, encoding. Yes, hot encoder or label encoders. Okay, if the order matters, then label encoder. Otherwise, if you just have to give a number like 0 and 1, you can use hot encoder. All right. All right. So this is done. Tomorrow we will do some next classification tool. Bye bye. Have a good